Have you ever noticed how clearly defined the ray of light is when a cashier at a grocery store uses a scanner? The laser from the scanner produces a steady, focused stream of light. This is an example of coherent light. Its photons, or particles of light energy, possess the same frequency, but its waves are in phase with one another. When you use a flashlight to light up a dark basement, on the other hand, the source of light is diffused and does not resemble the steady stream of light produced by a laser. Here, the photons do not have the same frequency, and the waves are not in phase with one another. We call this a form of incoherent light. These types of light, or electromagnetic radiation, are just one form of light that we can see with our eyes. There are also forms of light that are invisible to our eyes and possess different wavelengths, including gamma rays, X-rays, ultraviolet rays, infrared light, microwaves, and radio waves. With this in mind, we'll explore some important terms and properties of light surrounding the concept of coherent and incoherent light. See with our eyes, but this only comprises one part of the electromagnetic spectrum. This spectrum includes many forms of light which are distinguished from one another by their wavelengths. Light is also composed of magnetic and electrical fields, hence the term electromagnetic. In addition to visible light, you're probably familiar with another part of the electromagnetic spectrum, X-rays. We usually experience X-rays at the dentist, where they can assist in the detection of cavities and gum disease. It is also at the low end of dosage we receive in our daily lives. We can refer to any of these light waves in the spectrum as electromagnetic radiation, or energy emanating from a certain point in space, and depending on their source, they can either be described as coherent or incoherent light. These different light sources share some properties. All light waves contained in the spectrum travel at the speed of 300 million meters, or 186,000 miles per second. The scientific symbol for the speed of light is c. This is true whether the waves are coherent or incoherent. Moreover, the speed of light is constant throughout the known universe, a characteristic which was first described by Albert Einstein in his special theory of relativity in 1905. Light can also exist as both a wave and a particle. We saw this in the introduction when describing the physical characteristics of coherent and incoherent light. These particles of light, or photons, that were discovered in 1905 by Einstein, contain a particular amount of energy, or quanta, that also contains a certain frequency. The wavelength of light is the distance between the crests, or peaks of a wave, or between the lowest points, or troughs of a wave. The frequency of a light wave is related to its wavelength. It is inversely proportional to the number of times a specific wave group passes a particular point in a second, and is measured in cycles per second. Thus, the amount of energy that a photon possesses is directly proportional to its frequency, but inversely proportional to its wavelength. You can visualize this concept when you tune into your favorite radio station that broadcasts at a particular frequency, along with an associated wavelength of radio waves that can be calculated. These light waves can also be classified as either coherent or incoherent. Light in all forms exists as both a wave and a particle, called a photon. The energy of the photons for a particular light wave is proportional to its frequency, but inversely proportional to its wavelength. Coherent light is a form of light whose photons share the same frequency, and whose wavelengths are in phase with one another. The light from a laser, such as a cashier's scanner, is a perfect example. Incoherent light does not contain photons with the same frequency, and does not have wavelengths that are all in phase with one another. This type of light is diffused, like that of a flashlight, rather than a steady stream of light as with a laser. While we use the common term light to describe the light we see with our own eyes, there are also forms of light or electromagnetic radiation that we cannot see, such as gamma rays, X-rays, and radio waves. Together, these visible and invisible forms of light make up the electromagnetic spectrum. The forms of light that fall on different parts of the spectrum possess characteristics that may then depend on their wavelength and frequency. All forms of light travel at the speed of 300 million meters, or 186,000 miles per second, written as c.